Hi, in this video I'll review some problems involving the at least one probability. The first example states the following. In LA County, around 70% of baseball fans support the LA Dodgers. If 3 fans from the county are selected at random, what's the chance that at least one of them support the Dodgers? Well, whenever we see that phrase at least one, we always have to compute it using the formula 1 minus the opposite. None of them, in this case, would be fans of the Dodgers. So we have the probability that a person is a fan of the Dodgers, that's 70%. We need the chance that the person is not a fan of the Dodgers. So that's calculated using the complement rule. We take 1 minus, convert 70% to a decimal, 0.7, that's going to be 0.3. Now to calculate the at least one probability, it's 1 minus none of the 3 are Dodgers fans. Well, the chance of not being a Dodger fan is 0.3, and since we're choosing 3 people, we raise it to the third power. 0.3 to the third is 0.027. 1 minus 0.027 is 0.973. This is an example where we have independent events because we're selecting a small sample from a large population. In the second example, these are dependent events because we're selecting objects from a small group and not replacing those objects back. In this case, the objects are employees at an office. So it states, in an office, there are 4 secretaries, 6 accountants, and 2 receptionists. If a committee of 3 is formed, find the probability that at least one secretary is chosen. So keep in mind there are 12 workers. These are dependent events because every time we select a person, the probability is modified. So applying our formula, it says at least one secretary, that's going to translate to 1 minus the chance that none of them are secretaries. So it's 1 minus the chance that the first person is not a secretary. Well, we begin with 12 office workers, so we have to count all the workers who are not secretaries. Well, that's 6 accountants and 2 receptionists. There's 8 workers who are not secretaries. So it's 1 minus 8 out of 12 for the first person. That person is selected. We cannot reselect that person. So now when we select another person who's not a secretary, that's 7 out of 11. Remove that person, so the chance that the third person is not a secretary is 6 out of 10. We multiply these probabilities together, so it's 1 minus 14 out of 55, which computes to 41 out of 55. For the third example, it states the following. In the US, the percentage of people who have blood type A positive is around 36%. If 4 people are randomly selected, what's the chance that at least one will have a blood type that is A positive? So remember, we have to first calculate the probability that the person does not have a blood type. So 1 minus 0.36 is 0.64. These are independent events because we're selecting a small sample from a large population. So the probability that at least one has this type of blood type is 1 minus none of the 4 have that blood type. So 1 minus 0.64, and we're selecting 4 people, so we raise it to the 4th power. That's 1 minus 0.168, which is equal to 0.832. Thanks for watching this video.